Hello and welcome to the presentation of our aircraft, the X-27 Viper, presented by Matthew Altis, Jesse Hambrick, Thomas Kaplan, Donovan Kelley, and Olin. The problem that we were presented with is that modern fighters are extremely capable but also extremely expensive, limiting the fleet size. Therefore, we needed to design an aircraft with comparable performance but at a lower cost, and it also needed to have high survivability by incorporating stealth characteristics. Our objective was to create an aircraft that could meet the performance parameters shown on the right. Parameters that were unspecified in the RFP were set to have similar performance as the F-35. Our low-cost consideration means that we needed multiple units of our aircraft to be able to be bought at the price of one fifth-generation fighter. Our aircraft also needed to survive modern dogfights by using anti-radar and anti-thermal technology. A series of 3 weighted Q matrices were created for the engine placement, weapons mounting, and wing configuration. As shown in the final 3 view of our design, we selected a top-mounted engine with internal hardpoints and a delta wing configuration. All of our selections were driven primarily by the consideration of stealth. We selected bismillamide skin, which provides high strength at high temperatures, typical of supersonic flight, and is compatible with the stealth coating. The carbon composite was chosen for a balance of strength and weight in the spars and inlets. Titanium spars were added at intervals, as this was shown to supplement the aircraft's strength if damaged in the F-22 development process. Ceramic was selected as an improvement over titanium for thermal insulation of the engine exhaust as well as for fabrication considerations. A fiberglass nose cone was selected as it doesn't interfere with the avionics and has been proven durable in past fighters. The internal volume of our aircraft is shown in the 3 view on the right, which fits the assumed sizes of the engine and intake as well as the known sizes of 2 AIM-9 missiles and 4 AIM-120 missiles. Our fuel tanks were placed in the wings, providing a total CG that was determined to be about 16 feet from the nose and an aerodynamic center about 4 feet behind it at 19.88 feet from the nose. As fuel decreases, our static margin decreases as well, providing greater maneuverability throughout the mission without becoming unstable. Our nose gear was placed on the center line, 8 feet from the nose and under the aircraft's inlet. The main gear was placed at 8 feet from the center line and 21 feet from the nose to prevent tip over and over-rotation upon takeoff. We sized our aircraft using the Roscom method and utilized the sky map analysis to determine the best cruise altitude and velocity. We also conducted several sensitivity studies on important characteristics of our aircraft. Our final constraint sizing plot is shown below, demonstrating that our design point was limited by the active constraints of maneuverability and acceleration. Here you can see our aircraft performance relative to the F-22 and F-35. Our speed and service ceiling of 1,430 miles per hour and 58,000 feet lie right in between the 2 aircraft. Our aircraft has a slightly smaller combat radius and payload capacity than the F-22 due to its smaller size, while the F-35's slightly different design mission means it beats both of our aircraft in both categories. Even with the smaller range and payload values, the X-27 surpasses the RFP requirements while maintaining its low cost. The final design configuration is listed here in the format of an Air Force design fact sheet. Key parameters not previously mentioned are shown, along with the internal configuration of our aircraft to the right, with green representing the intake, yellow representing avionics, gray as the engine, and blue as the weapons. Now that comparable performance has been demonstrated, as previously stated, our aircraft is designed to be cheaper than current 5th-generation fighters. The Nicolai and Rand cost estimation methods were used for unit and cost per flight hour. Another sensitivity analysis on the fleet size was also conducted. We initially estimated a fleet size of 200 aircraft, which is the same as the F-22 fleet, and resulted in a unit cost of around $45 million. This was used in the following analyses for cost. As the chart shows, a fleet size of 1,000 units would bring the unit cost down to $20 million as well. The F-22 is the most expensive fighter in the US inventory, so our cost studies were normalized by its purchase and operating prices. While the United States hasn't bought any 4th-generation fighters since 2001, the F-15EX program provides an intergenerational option and is represented here along with the F-35. Previously, we showed that our aircraft was capable of carrying 2 fewer missiles than the F-22. However, for the same cost as one F-22, a group of X-27s could bring twice the payload to the battle and could operate nearly 10 times as often. Each generation of aircraft hopes to improve upon the last. With our performance and capacity for fleet size, our aircraft would strongly maintain our air superiority. Thank you for watching.